All right.
How to do it in the first place. So.
Well, you'll figure it out. We're having a review day tomorrow. And then we'll have a chapter review day on Tuesday, and we're looking at tests on Wednesday. So, here's your last new material.
Wait. Oh, and tomorrow's Friday.
Yeah.
Oh my God.
Okay, we've got tangent and cotangent left. So, we've got y equals, we're going to look at tangent x first.
Yeah.
Okay, you don't need a calculator. I don't want to waste the time to have you run up and get one. Just take a look. Tangent x. Okay, and my window is still set from 0 to 2 pi. Okay.
Oh, good.
Oh, God, yeah.
Already.
Okay, it's actually easier than it looks, because what you're seeing here is actually 2 complete cycles of tangent. You can see it's kind of a half swoop here. Then as I go, there's this, and then I got the bottom half. If I put this half with this half, I get one of these in the middle. So, tangent is just this, I call it the staying alive graph. Your hand starts down, comes up and disco. Staying alive with your right hand.
Are you supposed to be recording?
Yeah, I was gonna say.
Oh, I am. I just didn't put my thing on here. Not that they can see me anyway. Okay, so I call it the staying alive graph, because you go down and up. Staying alive. All right, so obviously the period length is shorter because there's 2 cycles of it here. And tangent's different. The one that they want you to see, if I go back, I'm going to change my window from negative pi, I wanted pi, not e, negative pi divided by 2 to pi divided by 2. So tangent goes right through the origin. And this is way stretched out. So, what we've got is tangent's going to start with an asymptote.
Hey, you said it right.
And finish with an asymptote from negative pi over 2 to pi over 2. Hits the origin. And what number is sitting in the A spot here?
Wait, 1. For pi over 2 after that, or is that it?
That's it.
That's like where the...
Where it ends and where it's going to start again.
No, I mean, can you put the tick marks?
Are there any marks in between them?
Yep. The 5 marks. 1, 2, 3, 4, 5. 5. Same as before.
No, I mean, where is the negative pi over 2?
Where that line
Right
is.
here.
Okay.
And here. Okay, that's what you wanted. All right, what number is sitting in the A spot here?
0. 1.
A 1.
Quick question.
Yes?
Why is it pi over 2?
Because it is. Okay, so where the 1 is going to come into play is its positive 1 here and a negative 1 here. So it's our A number. It is a point on our graph. And like I said, it just kind of snakes through here. So I call it, that's kind of concaved up. It's like the side of a cereal bowl. This one curves the other way. Curves down. It's like the upside down cereal bowl. So it makes a little change in direction right there at the origin. So, what we want to know about tangent, its amplitude. Is amplitude still the definition of axis to the max? Can I measure the distance from the axis to this max value if it goes up forever? Undefined, so NA. But the A number is going to be on our graph. The A number affects the second and fourth value. Period. How far is it from negative pi over 2 to positive pi over 2? What's that distance? That's a distance of pi. The period length for tangent and cotangent is not the same as the other four. The other one, you had to go all the way around the whole circle before it started to repeat. This one, you're only going halfway around the circle before it repeats. So the period is pi on tangent, not 2 pi.
Don't get the whole going around circle.
Don't worry about it, because that's how 2 pi is all the way around the circle, from 0 to 360. You're at the point of memorizing if you haven't figured it out yet. Okay. And then our vertical and phase are going to be in the same spots in a minute. Now, because this does not start at the origin, okay, tangent's the only odd duck, there's a little formula that will give you your starting x value. So, the starting x value is determined by a formula, not the phase shift like it's just happened for 4 functions. Sine, cosine, secant, cosecant all start at the phase. Tangent does not. The first x value, I'll call it x sub 1, is this little formula. Negative pi over 2 divided by b plus the d. All right, so now let's do the table and make the pattern.
Wait, what's
D is the phase shift. That'll be in the, I'll put it after we put the A, B, C, and D in. Remember, the D is in the parentheses with the X. One, two, three. A formula. All right, so our starting x value, just on the normal tangent with no phase, vert, period change, nothing, is negative pi over 2 to pi over 2. That puts the origin in the middle. I'm just making this table for this graph so we can get the pattern for the y values. It's okay, don't worry about anything yet. We haven't done it. We haven't figured out anything yet. This is all just to get the pattern for the y's here. Because it's normal. That's where if there's no change at all, it's always going to start there. Until we start messing with some phase and period change, then things change.
This is going to be a ridiculous note card for the test.
Okay.
Yeah, really.
Negative pi over 4. Pi over 4. All right. Know that tangent is always centered between 2 asymptotes. So you know your first y value will always be undefined, so will the last y value. Then, if I think of this value here as below my axis, what have we been calling the below the axis? A min. Then I hit the origin, which is my axis. And then I went up from the axis. Technically not a max, but if I think max is going up, I go down the A value, up the A value. Axis value will be the vertical shift. So this would be negative 1, 0, and 1. So this was all to get the pattern. Undefined, min, ax, max, undefined.
Is that always like the pattern?
That's
to
the
tangent?
Yes. It's the pattern to tangent right here.
And then you just said ax is going to be the vertical shift?
Mm-hmm. Just like it was with sine and cosine. And we'll do this in a minute. What if? This one didn't have any vertical shift, that's why it's 0. It's on the y-axis. I mean, excuse me, the x-axis. So there's no vertical shift. Okay. Got that. Shall we look at tangent now, or should we do one of these? Let's do tangent. Get them both out of the way. Cotangent, I mean. Yep. Nope, it's the pattern. So if we look at cotangent, I'm going to change my window again. go back to, this one is going to start at phase 0 to pi. To pi. Y equals, how am I going to graph cotangent? What am I going to have to type in? 1 over tangent.
See, I did that with the other ones and it didn't show up.
I don't know what to tell you. Graph.
Your windows are out of whack.
Okay. Here's cotangent. What's different about cotangent?
It's just the opposite.
It's just flipped around. It's the other,
The opposite.
staying alive with your left hand.
Wait, what do we do?
Starts high. My left hand high. Goes down. That's cotangent.
What do we,
Tangent. Get them both going. What?
what do we do if tangent is flipped?
Oh, then it looks like cotangent.
That's it?
That's it. Okay. Yep, that's going to turn it into the other one. Yep. All right, here we go.
You know, you won't even have to teach next year. Just show your notes.
I could do that. That'd be obnoxious. I could never listen to myself all. That'd be awful.
Just leave.
I'd cringe.
Coffee break and here, learn.
Listen to your own voice coming off a recorded voice. That's terrible.
Hey, shut up, that's the one.
Okay, here we go. But cotangent
No, it's not. Don't make the lead fall over here.
again, cotangent is centered between two vertical asymptotes. The other one just happens to be on the y-axis.
I have one for you. Did you just do it? Yes. Absolutely.
So the first part is curved up. See how it's like the side of a cereal bowl? Then that curve flips over and then it's curved down. So again, the amp here is NA, but we will use that A number to determine our max and min, which is in the second and fourth spots, and they aren't technically max and mins, it just tells us which way to get going. Period is pi, and the starting x value here will be the phase. Just like the other four graphs, all start at phase. The only odd duck is that tangent. Tangent's the only one that does not start at the phase. Okay.
Wait, no, yeah.
Okay, I'm chilling. Phase is going to be in the parentheses. I'll do it on the next page here. So it'll be inside the parentheses just like it was with the other one.
Wait, I have a quick question
Yep.
about this amp thing.
Mm-hmm.
Why is there an E?
Because the A will help us determine our max and mins.
Wait, what's A?
A is the multiplier in front.
Okay.
And I'll do that on the next page right now.
Okay, so if it's tangent, is it
Oh.
going to have a print? Okay.
It might. They don't all have to have phase. Hold on, I'll show you. Patience. 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 Okay, so y equals c plus a. I can have cotangent or tangent b x minus d. Just like the other functions.
Just going next to the one we just did.
It's going to start our next example.
Wait, why didn't we do a table for that last one?
Oh, I forgot the table.
Yeah.
Oh, sorry. Oh yeah, we need the pattern. Good call.
Killing me, Schwartz.
X. We need the pattern. Totally forgot. Y. So we're going 0 to pi. The period is shorter for tangent and cotangent. So what does that put in the middle? Pi over 2. Then pi over 4. And then
3 pi over 2.
3 pi over 4, 3/4.
Pi over 4.
1/4, 1/2, 3/4. All right, the y pattern, that was the whole point of doing the table here. Tangent and cotangent are both centered between asymptotes. So your first is undefined and undefined. So, cotangent is starting high, hitting the axis, finishing low. So the pattern is max x min. And my max and min are determined by my a number. My a number here was a 1. So that's why I've got the 1, the 0, and the -1. So there's your pattern for cotangent. All right.
Is there going to be like trick questions saying like negative tangent?
Mm-hmm. All right, so the powers of the A, B, C, and D don't change. What does C give us? Vertical shift. Vert.
Wait, what is
This is like the general equation that could have A, B, C, and D all incorporated into it. What does A do for us?
Amp.
You know, it helps with the amp, or it gives us our max and mins. Let's just go max and mins, because that tells us how much to go up and down to find our max and mins from our axis. The B, what does that affect? Period. What's the normal period for tangent and cotangent?
Pi.
Pi. So this time, instead of 2 pi divided by B, it's going to be pi divided by B is going to give us the period. And then the D?
Phase.
Phase.
Just like regular, like if it's negative.
Yep, if it's a minus D, we go to the right. If it's a plus D, we go left. Okay, are you ready? No, she's not ready. Okay, 1 plus 3 cotangent 1/2 x. Okay, no phase shift, so we don't have to do any simplifying. Amplitude. To get correct full value, full points on the test, what are you going to tell me here?
NA.
NA. But what are you going to remember for the table purposes?
Max and min.
Which is what number? 3. The 3 is telling us how far above and below. Period. Because it's cotangent, it is pi divided by the B.
Why is it 3? Okay, I understand that it's 3 from the cotangent,
Mhm.
but like when you graph it, is there going to be a dot at 3?
Well, almost at 3 because I have vertical shift, it's not. It's going to be the distance from my axis to that, what I'm calling a max.
So technically 4.
Yep.
Okay.
All right, so that's coming in. What's my B number here? 1, 3, or the half?
Ah.
So what am I going to get for the total period? 2 pi.
Literally, just write that down in my notebook.
Vertical shift.
None.
1. Up 1.
Wait.
It's this one up here that's added on.
Oh.
And phase?
I think I get those.
None. Because there's nothing in parentheses with the x. Okay.
That's a lot for one gap.
And if we need to take an extra day next week, we can.
Can I already say that we...
Okay.
I'm so confident in my answer.
Yeah. Well, you just did the wrong algebra on the start. Otherwise, with your wrong number, you did everything perfectly.
she did.
That was a -1
She...
out of about 10.
10.
On one of those tables and graphs, no, there's a lot of points in one of those problems.
Wait, so on the test you wouldn't have marked every single thing wrong?
Oh, no, it
You
one
ever heard of
one
knocking all
point
your eggs in
wrong.
one basket?
Yeah.
Well, obviously not.
So, here we go. Starting x value. Cotangent does start at the phase. How much phase do I have? 0. 0 phase, so it's going to start at 0. And it's still going to be phase plus period, which is going to be 2 pi. And so these middle ones are easy here. Pi over 2, 3 pi over 2. Okay, if I want to start my graph.
Oh, what?
I have a vertical shift of 1.
Oh. Oh, gosh.
So a vertical shift of 1. So that's a new horizontal axis. Okay, the pattern through the y's. The easy points are to fill in the first and last y's. What are they?
Und and und.
Und and und, because it's their asymptotes. And then look back at cotangent's pattern. What's cotangent's pattern for those 3 middle values? Max, ax, min. Okay, so if my axis is at 1, because I have vertical shift, so my middle value is here, that's at 1. I'm going up how many from that to get to my max? 3 more from that is going to bring me to 4. 4. And if I go down 3, where am I going to be at? Negative 2.
Okay.
Okay. Yep. One more, yep. I want to do a tangent. Because tangent's the goofy one. Then I'll throw in some phase.
So, what's happening? What? Will you look up your graph?
Yep.
So it's at 1,4? Is that at 1,4?
Yes. Okay, good?
You're gonna get ink poisoning.
Chewing gum is very complicated. It's not connected to anything for the wall.
Why? What are we doing?
I'm chilling still.
Okay, you can unchill.
All right. I'll throw everything in here except a flip. Let's go.
Why not?
Because you can handle a flip.
No. I don't know if I can, Jordan. Really, I can't.
Okay. What are we going to do first?
Find the amplitude. Well, let's go ahead and list them. Oh.
No.
Put it in the standard form.
Standard form. What number do you see next to the x?
2.
A 2. So what number do I want to see out in front of the parentheses?
2.
A 2. If I saw a 1/2 there, I want to see a 1/2 out here. Kenley, who taught everybody wrong yesterday. 2.
I actually did it right too, and then Kelly was, and I got mad. I was like, Kelly, how do you get that? She's like, didn't really understand.
You could have looked back at the notes, because I did one with a fraction yesterday.
Well,
What's going to be left in parentheses?
x minus pi over 2.
X minus pi over 2.
I always not pay attention to that minus
Okay,
or
wait.
plus and then I go the
So
wrong
you
way.
got the 2,
Because I see a 2 next to the x.
so you divided it by 2.
So I take that 2 and I put it out in front. See, I never change that number. That stays exactly the same. Because when I distribute back in, I've got to get that back.
We gotta.
Motor. Okay. Amp.
We got a motor.
NA.
I gotta leave.
What's going to help me find max and mins?
3.
A 3. Period is pi divided by the 2. The B is a 2. Vertical shift. Negative 2. Phase.
Right, pi over 2.
Right. Pi over 2. Okay.
I have a question.
Yes?
You're trying to find the last x on the table.
Mm-hmm.
Add phase plus period.
Well, not tangent. Tangent's the special one.
Okay. So if we're not doing that,
We'll still add a period to the starting x value once we find it. So tangent does not start at the phase. You've got this little formula to follow.
but say we're doing stuff that we do yesterday.
Yep.
And you add phase plus period.
Mhm.
Phase is right.
Mm-hmm.
Pi over 2.
Yep.
That means it's negative.
That means,
Do you incorporate the negative?
no, you look at the right. The right would put you at a positive 1/2. That's what I use as the 1/2, positive 1/2 when I do the. You take this table value. So, tangent does not start at the phase. It's that little formula. So the x1 formula I'll put there. And that's in your notes, so definitely have the x1 formula written down. The x1 formula says negative pi over 2. Divide by the b. What's my b? 2. Then add on the d. What is my d?
Negative pi over 2.
Because it's a right move, it's a positive pi over 2 that I want to use in here, not the minus that's up in the parentheses. Are you okay with that? Well, so maybe I should say plus phase here instead of D. Maybe that will help you.
Yeah.
Phase.
Are we?
Because if the phase is a right, you put in a positive number. If it's left, you put in a negative number. How's that? Instead of saying D, I'll put phase there.
Can an X be undefined?
It's not going to be.
So is it technically the opposite of phase?
Yeah. Oh. It's the opposite of D.
That's fine.
Yes. D and phase aren't quite the same thing. Okay, so I have to take care of this first. I got a fraction divided by 2. So how do I do that? Multiply by 1/2. So that's a negative pi over 4 plus pi over 2.
And then don't you have to times it by 2, so it's
Yep.
under a 4? Never mind. Don't listen to me.
Yep. So that will be negative pi over 4 plus 2 pi over 4 is what? Positive pi over 4. Because I need a common denominator to add. Yeah, absolutely.
Thank God.
So so that gives us
Our starting x value.
All that.
All of that. So there's 2 points on the test right
We're
there.
going to have to move it back up.
Okay.
and we still do that period and the phase.
So we're going to take our starting x value and add on the period.
Okay.
So it's going to be x1 plus the period.
Is it just a coincidence of the period and the phase in this one I was saying?
Mm-hmm. Yep.
Because
So,
usually it's the period and the phase that act together.
So x1 is pi over 4, so that's a 1/4.
Wait, you can move it back down.
Plus the period is 1/2. What's 1/2 plus a quarter? Common sense. 3/4.
I changed it.
That will be 3/4. And now it's your averaging to get the middle. So if I add, that's 1. Cut in half is pi over 2. So that would be 2 over 4, 3/8. And then 5/8. I can fill in und and und. And the pattern is min ax max I like to start on the axis. Where's my axis at? -2. I want to go down to my min from -2. How many below the axis am I going? 3 below -2 is going to take me where? -5. And then, nope, I'm at -2 when I go up 3. There you go, third time's the charm.
Why? Oh, I added 5, I'm not sure why.
All right, and now we just graph. So if I make this, it's all positive, so I'll make it small here. Squeeze it in here. They're all positive x's. Everything's to the pi over 4. 1, 2, 3, 4. 3 pi over 4. My axis is down at -2, and I got to go down to -5.
Okay, I'm leaving it. Wait, I need the homework.
Yep, I'm going to shorten this up a bit, and we'll do more tomorrow, maybe more on Tuesday, then review Wednesday, maybe test will be Thursday. We'll see how you're feeling next week after a couple of reviews here. Let's try. Yeah, it's way too many of those. Let's do 4 of these. 16, 19, 32, 41. 4, that's it. Just try 4 of those. So we've got this, 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 and then we're at -5 and +1. Down is curved down, up is curved up. And then there's the 4 you get to try. 4? 4.